Thanks, Carl. Sounds like the mic's working. Yeah, is that good? Yeah. Super. Well, first of all, enjoyed the morning sessions, both listening to them and participating in them. And this is a real fun session to give too, the Corero vision. It's a privilege, really, I think, to speak on behalf of Corero. And I'm going to keep it high level because you'll also be hearing from the people on the front line who are implementing our product roadmap. Sean Newman, who's here, works for me, is our VP of Product Management. And then Julian, obviously, will be speaking, who reports into Carl, Head of Engineering. And then there's Jason, Head of Global Sales Engineering. And then, of course, the sales execs too. Also on my team, Corey, still, who you heard from this morning. So there's a lot of people going to talk or will talk to you about the next level down, the details or the specific things we're doing. So what I wanted to do in this session was really, I guess, take advantage of that vision thing title and just riff about why we think it's going the direction we're going to talk about and why we, as Corero, can have ambitions, if you want, beyond our size about making a difference, a little bit like Sean was saying before lunch, making a difference in this battle against evil forces of the cybersecurity, cyber criminals, etc. So, click. Oh, it's working a second ago.
Jason, did you take batteries?
Elvira, the clicker stopped for some reason. I think it did work a second ago. Try again.
It was part of the show, it's availability.
And then I'll do it forward. Okay, there we go. It's working again. Thank you. So, going to look 5 years out, 2030 and beyond. And what I'll talk about is how the internet, this thing that we use every day, and as Rob pointed out, we're just so dependent on in many different shapes and forms, how we're going to get to trusted internet networking in the future. And there's a lot of threads or streams that weave together to support this, and then finish up with, why Corero should be able to make a difference in this space. So our view in general, and this was also mentioned this morning, is that network security is actually different from application security. It's not an instead of, it's an as well as. And in order to have a secure or trusted infrastructure, they have to cooperate. And that'll hopefully become clear, or at least not that we're defining the two of them, but what will become more clear during our discussion today is how that interaction between them makes for a stronger cybersecurity solution. So Corero, its roots are very much, as the name of the company suggests, in the network security side. And we can help people who are protecting our applications, but we do understand, as somebody was mentioning earlier, that the application space is different from the network space. It's not only different in the stack where it lives, but it's also different fundamentally in how it works and how it operates and the constraints, whether it's encrypted or not encrypted, whether you actually know what's going on or not, whether there are any standards governing the interactions of applications. And that'll hopefully be part of the story we tell here. So, starting point, our view, network security is different from application security, but together, if they work together, coexist and cooperate, then we can achieve a much greater level of trust in the systems that we build and use. So, examples to clarify this position. On the network security side, we have our favorite topic where we spend most of our time, DDoS today, but we also have DNS, BGP, the protocol for route information communication in the internet. We have, of course, the internet protocol and all the associated protocols, VPN, SD-WAN, SASE, zero trust networking or zero trust network access. So zero trust has a role to play in networking, even though these days it has a much stronger influence or role to play in the application space. And many of these, if you're in security, or if you're a CISO, if you've tried to protect a network, many of these terms on the left-hand side will resonate when people talk about network security. Of course, this is not a formal standard, so there's no exactly correct definition of network security. We're talking about a space or a domain of capabilities. And over on the right-hand side, I just free-form listed a bunch of things. There's many, many more, but obviously encryption, identity, access management, hot new topic microsegmentation, linked again with zero trust, all of the WAF, WAP, API protections. You heard Sean mention about some of the work they're doing with NeoSec and now more recently No Name, but there are lots of other players. The botnet space, IPS still has a role, even though we were sort of ribbing or laughing about it earlier. You know, IPS type protections are important. More often talked about in the context of WAF and OWASP profiles, etc. these days. Become more specialized, I guess, than the generalized case of security back 10 years ago. The whole software life cycle, been a couple of good incidents recently that have shone a light on, you know, how you might have a bad employee who puts a backdoor in code, a nation state that compels a company to put a backdoor in, or even there was an open source example of coercion. And if you haven't read about that recent open source threat that was inserted, very long campaign over a couple of years, how somebody campaigned to get changes, actually made good changes to open source, and then turned it around to pressure the poor person who was managing the project, that criticizing them publicly that they weren't moving fast enough, accepting changes fast enough, and then ultimately slid in a malicious change into the open source. Right? This is not trivial stuff. This is long-term orchestrated efforts to compromise your application security. And then, of course, the whole supply chain, the cloud providers you use, etc. So these two worlds are going to have to coexist, in our view, to achieve trust in the future, overall trust, that is, in the infrastructure. So our value, the value from network security, I've highlighted a few bullets here. Carl spoke to this earlier today, particularly about availability, but why people need or want network security is to achieve availability, to be comfortable with a level of automation so they don't have to do everything or double, triple check everything with humans. To be able to automate, roll things out, infrastructure as code, you need to know that what you're deploying is going to be secure. So the whole integrity of the solution has to hang together if we're going to trust it with our most important applications. And then something I've always loved is observability. If you can't see what's going on, then what is going on is probably not what you expect. And that's just been proven time and time again. People think they know how something's working, or they think they know what the problem is, but if you can't really go in and have a look, then you're literally flying blind while you're navigating through the storm. So observability is something you should get. You do get it from Corero's current products, and we think we're going to take it to the next level in terms of observability in the future, all related to network security and this trusted internet. So our journey to get to this fantastic place in 2030, or this trusted internet mode of operation, is we must leverage the past. And this is a lesson, it's a life lesson I've learned. Had a chance to work on some fantastic projects and always seen the future in some ways as an evolution of the projects we've worked on in the past. And my physics background, I'm a scientist by training, a physicist, is you sort of realize you don't invent the future so much as discover it. You know, the laws of physics are the laws of physics, and we spend a lot of time trying to understand them in finer and finer details. Sometimes, you know, we have approximations of them, like Newton's laws of mechanics, and then other times we take them further with Einstein's theory of relativity. But it's there already. You just have to like peel back the onion or uncover what secrets are below the surface. And when we're doing that, you know, even in a engineering and even in a marketing and sales phase, we have these hypotheses of what might sell or what customers are telling us they want, but we have to validate that by observation, market research. We have to do some experiments sometime, get a product in the market and see if it sticks, see if they buy it, see if they'll pay for it. Free trial, will they pay for it at the end? And this market engagement, Carl pointed out, we're looking for design partners for our next level of solutions in this space or on our journey. So very much participative in that sense. So now I'm going to use a couple of my career examples to show you how I engaged with this thing called, eventually became the internet, but the TCP/IP protocol. So I lived a very lucky time frame, if you will, with my career, because I spanned some fantastic innovations, and one of them was the birth of the internet and the introduction of TCP/IP. So in the early 80s, I was a physicist, a scientist, and I was at CERN. After graduating from Imperial in London, I got sent as one of the British representatives of this 12-member nation lab, discovering the future. We were looking for quarks and bosons and everything. We built this ring underneath the countryside in the Swiss-French border at CERN, the High Energy Research Lab. It's like 16 miles in circumference. So it's underground in the limestone, a tube about the size of a tube tunnel or a subway tunnel, and it just goes around in this huge ring. And we decided we were going to put a pipe in it, evacuate it, and then at the time send electrons and positrons around it to discover, laws of physics, and perhaps our future of what was going to happen to the universe. So the reason I mention it is this accelerator I was working on. It was called the Large Electron Positron at the time. It's now become the Large Hadron Collider. So they upgraded it in the last 20 years to circulate protons and heavy particles as opposed to electrons. But in the mid-80s, this project I'd worked on decided TCP/IP was necessary to network the computers to control that ring. There were so many computers needed to control all the magnets and the beam injectors and the experiments that they made a move from the proprietary networking systems of their vendors like IBM or Nordstata or all of the leading computer manufacturers at the time, and they chose in the mid-80s TCP/IP to be the necessary protocol. And you'll see in the next slide why that was so important. And I thought this was, obviously this was big science. Even as a young man, I was amazed by what we could accomplish here. My job was actually making the vacuum in this system. So there's a 27 kilometer or 16 mile tube that we have to create an ultra high vacuum in it. It's about the same vacuum as the dark side of the moon. So it's way beyond anything you would ever see on Earth. And I had to simulate that and then help the guys design it. But the reason it was important is at that time, we were all working on green screens, like you see on the left-hand side, right? Black with a green phosphor and a lot of boring text. Except that we had a couple of words that we used for 10 years. So long before the web, we used to browse things. Browsing documents meant you just looked at them. You just clicked away at the documents. A bit like when you double click on a directory and you go to the next level down. You double click and you go to the next level down. You browse the directory, and if you go back up to the next. You could do that with documents. And there was this thing called hypertext, like the little highlighted. If there was a highlighted word, it meant it was hypertext. And if you clicked on it, you went to the document that the text pointed to. Super important when you're working on a big project like this research lab, because the documentation and experimentation of how everything worked, you had to read a lot of stuff and you could click through the screen. So we had that system in place. But it was that move to TCP/IP to control the computers for a totally different reason that then meant this hypertext stuff was running over a TCP/IP network. Still nothing fancy was happening, but you can see, how two things were coming together. And the other interesting thing at that time is that many other places were discovering the same thing too, that TCP/IP was a very important protocol for networking dissimilar systems. Actually, it was a good sense. So anyway, we were browsing, but there was another physicist there who, just like me, crossed over to the dark side and left physics and went into computer science. Tim Berners-Lee, right? And so he was at CERN working on hypertext, and also in the later that decade, CERN decided to connect to the TCP/IP networks of all the other labs. At the same time, in parallel, ARPANET had also selected TCP/IP as its protocol. So there's lots of things going on. But Tim, of course, he then was able to do those hypertext links to documents, not just inside the CERN library, because before everything was in your own domain. It didn't go to other people's computers or even to other vendors' computers. It was all just your private local document library. So it was just browsing your own stuff, really. But he realized that if he took that hypertext and created a protocol so that you could exchange those links between these systems that were connected now by TCP/IP, and then also coin a markup language so that you could format the data, then on his screen there at CERN was the first page of the World Wide Web, right? So you see this thing take over from this point on, and this is what I mean about learning from the past. It wasn't just, he didn't just come to work one day and have a good idea. It was the result of years and years and years of using systems, and then a change happens and off you go down a new path.
So you're going on record as saying that not Alexander, but you founded the internet?
I was a lucky spectator. That's what I'm saying, a lucky spectator. So also after that, IBM called me up and said, hey, why don't you come to the dark side, commercial, right? Leave the academic world and come to IBM. So I joined IBM Research because they said, oh, we'll teach you how to make chips, write software programs, test things, do simulations. So I joined IBM, and there's something good stuff was happening there. IBM had one of the best networking technologies in existence at the time, Systems Network Architecture, SNA. And it was a fantastic system as long as you had a fixed hierarchy of wiring things up. So you had to basically know what network you wanted to build, and then SNA, IBM's solution, would let you build it. It wasn't good for dynamic, unknown, expanding, continually improving networks like we know TCP/IP is. But to their credit, the smart guys at IBM, Yakov Rector, in fact, this is Yorktown Heights, their research lab that I was fortunate enough to visit. He and his friend Kirk penned BGP, right? And also convinced IBM that even though they had this fantastic network architecture, they should move to TCP/IP because it was the way of the future. Their vision was this was going to be the way businesses, not just academic like research labs, but the way businesses connected to each other. And so by '89, I think that became the first IETF draft, and BGP was born. So again, where we are today very much is a progression of learning from the past, but casting it forward or projecting it forward. So another few years go by, and yes, that is me 25 years ago on this article. But the kind of stuff that was happening, I was also participating in a consortium called Power Open, which was Motorola, IBM, Apple, and a French company called Bull. I was their representative. And this, again, was to make TCP/IP the interface of choice for networking between these disciplines. It wasn't going to be Apple Talk. It wasn't going to be IBM's proprietary communication. It was going to be TCP/IP again. And you know where that led. Windows 98 came out around that time. That was the first one that had TCP/IP networking built in. And again, you can start to imagine what happens in terms of looking forward. And even 25 years ago, the company I was then running, we introduced a router, an access router that was dual homed, BGP, IPsec VPN, but it had two 100 megabit interfaces. So now in that time frame, we've gone 1,000 times faster now, right? Just in that time frame from when these products were used. And this was used by UUNet to roll out their business service across their network. So if we keep going forward from those kind of steps and draw on that kind of trajectory, if you will, of TCP/IP and networking and the internet, we start to, I think, see where we think we might be in 2030 and beyond. So an important factor that's grown dramatically, as you heard Sean and I talk about in the last 20 years, is cybersecurity. Our focus in the earlier talk was DDoS, but as we were talking about with application security, there's a lot more issues to think about than just the DDoS aspect of cybersecurity, and it's ascendant at the moment. If we don't work together to address cybersecurity problems, we're not going to be able to take advantage of the next enabling leap of the internet and on the network side, TCP/IP networking. So it's important to, with those commercial kind of data points I plotted following the scientific ones, we do need to understand how needs and means will define the next set of cybersecurity solutions, because it's not just the best technology, it's not just the best idea, it's got to be linked or merged with a commercial opportunity that will drive the investment. A good example is the ChatGPT LLM progress we've seen recently. I mean, that nobody's buying that. Somebody's investing in it. They're spending hundreds of millions of dollars because they believe we're going to get somewhere good. So it's not a commercial justification for doing it in the sense of, I had an idea, I'll build it, they'll buy it. They're plowing hundreds of billions probably into free, LLM, ChatGPT queries for you and me, in betting that the future is going to pay off. The same thing happened with the web. In that UUNet network on the previous page, that was a belief that IP networking was going to be important, that ISPs plowed in, and a lot of us, we never really paid for the internet access that we got, paid the right dollars. It was very, very much funded by all the investment that was being made in that area at that time. Of course, now we're reaping the benefits with the advertising streams of revenue. So that leads us then, we're seeing growth factors over that period of up to 1,000. That leads us to where today we see applications on the left, now more and more cloud native style applications, what was web became web services. Another example of you wouldn't define web services unless you had free, like HTML communication mechanism around the world that came from web browsers. The same thing's happening with microservices, the Kubernetes based systems, cloud native network functions. There's a lot of exciting stuff happening on the application side, but they still connect to networks where we're using public IP addresses. And in the sense of an attacker and defender, there are source IPs out there. Sure, they're all zero trust, but they can still connect to you. And we have to decide whether we're going to let them into the system in order to play in the application side of the equation where all these fantastic services live that we need to take advantage of to pay our bills, to help Google find us our way, to book our airline tickets, whatever it is you do on all those little apps on your phone. The messages, the packets need to come in from the left-hand side, and that's where taking advantage of all that TCP/IP related networking brings them into the domain of network security and what we do. And at the top there, we've got these two views of what's going on the network side and at the same time what's going on the application side. It's a bit of a Wild West at the moment, in my opinion, on the right-hand side, in that the service meshes and the deployment, the API explosion that we were talking about, it's going faster than the security procedures can keep up with. So there's a lot of exposure, hence the interest in companies like No Name that can try and bring some order or process to securing the application space. So our plan, speaking in terms of a vision for Corero, is that we're going to innovate in this space. We're going to use the domain knowledge that we built over the last decade, and also our experience with attacks, with what customers need, how their networks are built, and also our curiosity, because it's not obvious sometimes what the right solution is. We also, of course, recognize we're a business, and customers like to buy from healthy businesses. They don't like to buy from failing businesses or even stagnant businesses. So most of the businesses we talk about around here, we all want to be growing and be making a profit. So we recognize those commercial drivers and financial incentives and the business model we come up with, they're equally as important as the technology that we're developing and inventing, right? So it's not just the best widget, it's also got to be matched to a route to market for a price that the customer can afford to pay that more than covers, your costs, so you can make a profit. So we're going to invent or adopt the products, services, tools, etc., that will give Corero, we think, a competitive advantage in pursuing this network security evolution that we're talking about at this conference. And as I say, you'll hear more details of specific roadmap items from presenters later in the two-day series. So, securing the evolution of the network. If we're going to get to that trusted internet vision that I mentioned at the beginning of the presentation, we've got to look beyond DDoS, because in the cloud-native computing world that's rising rapidly and taking over the discrete server kind of service, we've got all of these new technologies or areas of expertise. Is it the buzzwords, as it were, of cloud-native, the containers, the CI/CD, the zero trust, the stateful and stateless designs, the desire to do everything through APIs or automation or DevOps. That's what's allowing us to scale with flexibility, with immutable, changeable, immutable sort of microservices. I mean, I'm an observer in that world. I'm not a participant. I don't build systems, but just watching, just observing what's going on, it's unbelievable. It reminds me of some of those early days when URLs first came out and people started to innovate, deliver graphics, and then of course CDNs popped up, and we went to web pages, then we went to web services. I do see a very exciting explosion of future possibilities on that side of the equation, driving the need to secure the networks that they're going to have to communicate on to get to either the devices or the machines that they need to communicate with to deliver a solution. So what that rounds off into when we look at summarizing our vision, it really is one of trusted networking. It's more than just DDoS protection as we go forward. It's this confidence that your network will be there when you need it, the availability, whether it's through redundancy, resiliency, or some of the issues that Rob mentioned earlier on, the hardened nature of it. I mean, I'm not suggesting Corero is going as far as the tamper-resistant, electromagnetic pulse-hardened systems that Rob, but that's why we've partnered with them, right? We don't have to build everything ourselves. We can adopt great solutions too. So that was the sort of spirit of the recent partnership with Semper. But what it means, I think, if we break it down into some takeaway bullets that'll hopefully frame some of the details you hear about, we need network observability, but we need it in a stateful sense. And this is going to be a great enabler. By stateful, I mean we don't just need to look at the bits per second or the packets in front of us. We need to know what the sequence of packets has been. Just like LLMs look at the sequences of words. I mean, when ChatGPT parses your question, it's looking at the sequence, the words you've used and the sequence they come in to figure out what it is you mean or you want to do. That's the way, even at the network level, we can figure out whether this communication that's coming in, packets at 100 gigs or even faster, is a genuine communication. We've got to start tracking by state, by source and destination IP and ports and protocols to understand instantaneously whether this next word, as it were, that pops up is the correct one or not, or likely to be the correct one. It doesn't have to be perfect, right? It just has to be great. The policy-based admission control, we have to stop some of this bad network traffic at the edge or at the source, or even as somebody was wildly suggesting, maybe we cooperate with the upstream providers. What a crazy idea, but it doesn't happen today. Like if we have a bad problem here, we can't tell up the BGP ASN chain, right? We can't tell them, stop this traffic before it, piles in and becomes a perfect storm at one of your exit points of your network. Nobody's prepared to trust each other in order to, even though we know the information, we know what we want them to stop, but there isn't a way to stop it. We currently have to tell everybody in the world to divert their traffic to a cloud solution, cloud DDoS solution. So admission control, which has been around forever, all the way back to some of the technologies I used to use 20, 30 years ago, class-based queuing from Floyd and Van Jacobson. But we now, I think, are in an era where we could deploy it because processing power, particularly with some of the smart NICs and the risk-based front ends, can do this at a rate that matches the incoming traffic. Synthetic network identity is another factor. And what I mean by that is we can't truly identify the source IP or the source of these packets, right? But there's enough information coming in those time series streams of packets for us to use machine learning to figure a lot of that out and to make a very good approximation of, is this a trustworthy source IP? But we're not doing anything with that information. It's just falling on the floor. The packets come in, we see a lot of features, we extract a lot of features, we use them instantaneously, and then they're forgotten. So there's, again, an opportunity to use our skills to learn more and synthesize whether this source IP should be trusted or not for the transactions it's trying to trigger. The fourth bullet, proactive and predictive automation, this fits in with something I know is dear to Sean's heart too, is if you can figure out where the attack's going to come from or what vulnerability it might take advantage of, why not put up your defenses before it gets in the door? Why not push out or push back the defenses that proactively will improve your, reduce your attack surface or improve your resilience to attack. Again, we believe that the essence of that is now possible with the processing power and the kind of storage and the other tools such as the AI or large language model kind of approaches. Just like they're using it to recognize images, we can use it to recognize API conversations or malicious source IP reputations. And I'm not talking about old-fashioned IP reputation here where it was typically bad, incorrect, and inconvenient. We're talking about a new level of AI-assisted synthetic reputation that takes into account a lot more factors that are relevant from the network security world and can be connected to the application security world. So one last link to mention there on application security. In that world where people are talking about examining decrypted packets or actually looking at the messages or authenticating the different services in a zero trust model, when they find a bad actor, when they spot that they are being either overloaded or they're spending way too much money to process junk requests, right? And I'll come back to that in a second. Wouldn't it be great if they could communicate that information and feed it into this synthetic network identity and say, this source IP is causing CPU utilization to skyrocket, or it's causing it's attempting to access systems or services that it shouldn't, right? It needs to be able to communicate that to the network security systems so that they can be prevented at the edge. Why do they need to be prevented at the edge? It's because one of the great things about these scalable application services is that if you feed in lots of junk packets, they'll spin up more resources and your processing bill will skyrocket, right? It's great having a system that can scale from 10 servers to 1,000 servers automatically, unless, that 990 of those services are processing junk messages. You've got to stop them earlier up in the chain, not when they've already got through to you. And those wasteful messages are often coming from malicious source IPs out there or bots further up the network. We've actually had customers come to us with that as a DDoS problem, big name customers, and there's no solution for it today. When they get attacked, the attacks are sufficiently similar to real world operations, they end up spinning up hundreds of servers to process them, and they just get, they get a huge bill for that. They don't go down, but 90% or more than 90% of the work they're doing is junk work, but they're paying AWS for it, because AWS doesn't give you a day off. You can't put your hand up and say, oh, sorry, 90% of my workload last month turned out to be junk packets. It's like, pay the bill.
Are you defining some sort of a control software?
At the moment, what we're saying is we have the ability to do selective admission control or blocking up the network, but there's no solution at the moment that allows the deep in the microservice world, the L7 kind of protections to communicate that securely and effectively back out to these systems. But we have a vision that should exist and that we can help make that exist.
Right. Forward looking, do you see any synergies between, because we do a lot of ingress traffic, manipulation.
Yeah.
Do you see any synergies between that in terms of mitigating some of these?
Great question, asking about the synergy that would come from correlating ingress and egress traffic. That is part of this solution, the stateful network observability, because we can't demand symmetry. The networks aren't symmetric anymore. Requests come in, requests go to a load balancer, they get sent to a server, and the responses from that server don't go back through the load balancer, they go out the fastest way back to the requester. So we need systems, stateful systems that can track the egress traffic and the ingress traffic separately, but then do the math or do the machine learning that puts them together and to understand what's going on. It's never perfect, right? But it can be 99.9%, right? You can asymptote towards, and we've actually done that for a customer. We did a great experiment with a customer. One of the DDoS challenges is ACK floods. I mean, an ACK, it's hard to know if an ACK's genuine or not. There's so many of them, and if you block them, then indiscriminately, you'll have terrible false positives. So what we demonstrated to one customer is in this bifurcated stateful observability, we had one system track the outgoing SYNs, and the outgoing SYNs populated white holes in a blacklist. So, they basically opened up windows saying, these guys, all we know is these guys have sent a SYN in the last few minutes. So if ACKs come back, it could be the round trip, right? Wasn't perfect, but compared to letting in all of the ACKs or blocking every ACK, it was 1,000 times improvement, right? That's the technique we think we can build on. I'm not saying we're the only ones doing it, others are doing this too, but we've demonstrated we can do it, and we think we could bring that to market in terms of a bigger solution for linking, application security to network security. So that's the high level view of our vision, right? You get the idea. There's a lot of history that we can learn from. It feels like we're heading towards one of these very busy periods in terms of cloud native processing. It's going to be multi-cloud. It's going to be alternate cloud as well as public cloud. But we think not just the role we can play, but as Sean was pointing out, it's our duty, in a way, on our side, particularly to come from our networking-based heritage and build what we can do, companies like Akamai and others, they're spending $500 million here, $500 million there to buy application security companies to bring it into the fold so they can protect their customers. That's this vision of trusted networking or the trusted internet that we think is achievable in the next 5 years. And that's why we're calling for design partners who've got problems. Maybe you've heard something I've mentioned that fits something you're challenged with or you know you'll be challenged with. We want to work with you to both help you discover what we could do for you, not just obviously for a win-win situation. You have a solution, we have a business, but back to some of that academic research, if you're doing good stuff with the right people, then usually it pays off. It's a little, in the venture world, because I, done venture-backed companies, it's sort of like you've got to be out there on the surfboard paddling around so that when the big wave comes, you're ready to surf in. You can't stand on the beach, with your surfboard waiting for the wave, and then when you see something, then decide you're going to head into the water. It's gone by the time you're too late. So if you can see it from the beach, it's too late. You can't see this from the beach, right? The only reason we know that this could be possible is because we've been doing this for 10 years, or some of us, even longer, and we can see where it might lead to in the next 5 to 10 years. Great. So that's the Corero vision, folks. Thank you very much for your time.